Today we're going to get into systems of equations and we're going to solve them by graphing. A system of equation is basically two equations that are paired up and they say find where they would cross each other. So you're looking for a coordinate where they cross each other. So we're just going to practice by graphing some of these slope-intercept form. Remember, negative x minus 4, you start with the y-intercept, which is negative 4. So you go down 4, you make a dot. And the slope is this negative 1, which if you think of it as a fraction is negative 1 over 1. So you go down 1, right 1, down 1, right 1. If you want, you can go up 1, left 1. And just draw your line through it, have your arrows going both directions. Try to hit those dots, unlike me. The second one, y equals 2x minus 1. You start at minus 1, and then the slope is 2, or 2 over 1. So you go up 2 over 1, up 2 over 1, up 2 over 1. Could go down 2 left 1. Now, if this was a system of equations, which it's not, they're just telling us to graph all three of these, then you would see where they cross each other, and you would write that coordinate. The coordinate there is negative 1, negative 3. So that would be your answer. That's where we're going eventually. This third one, 3x minus 2y equals 5. We're going to get it in the slope-intercept form. So first we would have to subtract the 3x. So we'd have negative 2y equals negative 3x plus 5. Then we divide everything by negative 2, which would give us y equals 3 halves x minus 2.5. So we go down 2.5, and then from there we can go up 3 over 2, up 3 over 2. Something like that. All right. So again, now we're going to have this system of equations, and we're going to solve them by graphing. You're going to learn other techniques that you can solve these with later. But graphing is a pretty easy way to find the solution. You're going to graph them both on the same graph and see where they intersect each other. So y equals negative x plus 1. Go up 1, and then the slope is negative 1, so down 1, right 1. If you wanted to trace it back, you certainly could. Second one, y equals 2x plus 4. You're going up 4, 1, 2, 3, 4, and then up 2 over 1. If you want to go backwards, you can go down 2, left 1. Hey! Down 2, left 1, down 2, left 1. And our answer for all these, our solution is where do they cross each other? Where do they intersect? Which in this case would be at negative 1, 2. If you substitute those in for x and y in both problems, it's the only coordinate that works for both problems. Y equals x minus 6. You start at negative 6, the slope is 1, so you go up 1 over 1. The bigger the graph, the worse my graphs get. Oh yeah, that's a rough one. Y equals negative 2x. The y-intercept there is 0, but you go down 2 over 1, because that's our slope, negative 2. Hey, that's where they cross, right down there. Something like that. Their point of intersection is right here, which is at 2, negative 4. That was a pretty rough graph. If you want to talk about rough draft, let's talk about rough graphs. All right. Y equals 3x minus 3. Go down 3. And then our slope is 3, so you go up 3 over 1. Up 3 over 1. Up 3 over 1. X plus y equals 1. Well, let's send the x to the other side by subtracting it. Negative x plus 1. If you start with the y-intercept of 1, your slope is negative 1. So you go down 1 over 1. Boom, that's where they cross. And that coordinate where they cross is right at 1, 0. Again, if you take this coordinate, substitute it in for the x and y in both equations, they both work. Now, there are some bizarre ones. You might come across lines that never cross each other. Whoa, that's wild. And then you might come across other sets of lines that are the exact same line. So if they never cross each other, that would be no solution because they never intersect. And if they perfectly overlap each other, that's called infinitely many solutions. So if you look at the first one here, let's readjust this formula. Y equals negative x plus 1. Slope's negative 1. So it goes like this. Second one, negative x plus 3. That 1 over 1. These are parallel lines. They have the same slope, so they never intersect each other. So this would be one of your no solutions. And this one, if we were to graph the first equation, get y by itself. So first we'd subtract the x. Negative 2y equals negative 1x plus 4. Then we'll divide everything by negative 2. Y equals 1/2 x minus 2. So we go down 2, and then our slope is 1/2. So up 1 over 2, up 1 over 2, 1 over 2. If we readjust the second equation, we'd subtract the 2x, negative 4y equals negative 2x plus 8. Divide everything by negative 4. That simplifies to 1/2 x minus 2. Now if you look, that's the same equation we got over here. So you'd start down 2, you'd go up 1 over 2. So it perfectly overlaps. It's the same line. So this, you would say, IMS, which stands for infinitely many solutions. Because there's all these little decimal coordinates in there that work for both equations as well. And then that's going to be it for this video.